Good morning, students. Today we are going to derive equations of motions. Okay, equations of motions are mainly three equations are there. That is, first equation V is equal to U plus AT. Second equation is equal to, this is the equation connecting velocity and time. Velocity time relation V is equal to U plus AT. Next, position time relation. Position time relation is equal to ut plus half at square. Ut plus half at square. This is the equation relating position and time. Next is position velocity relation. That equation is v square is equal to u square plus 2as. These are the equations of motion. In this equation, what is u? U is initial velocity. U is initial velocity of the object and v final velocity of the object. What is S? S is the distance traveled by the object. Distance traveled by the object. And T is the time taken for changing the velocity from U to V with uniform acceleration A. Okay. Understand? Now we are going to derive these three equations by graphical method. Okay. You can consider an object moving along a straight line with the acceleration A. And u is its initial velocity, v final velocity, t time taken. Now we are going to draw the velocity time graph of this motion of the object. In the velocity time graph, velocity is taken along y-axis and time along x-axis. This is uniform motion, uniform accelerated motion. So shape of the graph is straight line inclined to the time axis. During the time t and during the time 0 time, initial time 0, the initial velocity of the object is u. Okay, initial velocity of object is u. After time t, its velocity become v. Okay, moving with the uniform acceleration. So, the shape of the graph is straight line inclined to the time axis. But this is the graph. Okay. Now we can name the graph. For this point we can name as A. This point B. This A. B. This point we can name as C. And this point D. This is E. Okay, understand? Then what is OA here? What is OA? OA is equal to U. OA is equal to U. Then what is BC? BC. BC is equal to U. V. BC is equal to V. OA is equal to U. BC is equal to V. Then what is OC? OC എന്ന് പറയുന്നത് that is T. അല്ലേ? ഇവിടെ മുതൽ ഇവിടെ വരെ that is T. OC is equal to T. അപ്പോൾ OA എന്ന് പറഞ്ഞാൽ OA is equal to DC തന്നെയാണ്. അപ്പോൾ we can write OA is equal to U ആണ്. The same it is equal to DC. DC also equal to U. BC is equal to V ആണ്. Then OE also equal to P. OE is equal to BC ആണ്. That is equal to V. അതുപോലെ തന്നെ OC is equal to T ആണ്. അതുപോലെ AD is also equal to T. Okay. And also we can write BC എന്ന് പറഞ്ഞാൽ എന്താ? BC is equal to BD plus DC ആണ്. അല്ലേ? BC is equal to BD plus DC. Okay. Then using this graph, we are going to derive firstly velocity time graph. Okay, velocity time graph. Okay, from the VT graph, we know that what is BC? BC is equal to V ആണ്. BC is equal to V. OA is equal to U. OA is equal to U. BC is equal to V. And BC can be also be written as BC is equal to BD plus DC ആണ്. BD plus DC. Okay, BD plus DC. From here, what is BD? BD is equal to BC minus DC ആണ്. BC minus DC. What is BC? BC is equal to V ആണ്. What is DC? DC is equal to OA. DC is equal to OA തന്നെയാണ്. So it is U. We can write BD is equal to V minus U. Okay. BD is equal to V minus unit. Then we know that acceleration of the object. Acceleration. What is acceleration? Acceleration of the object from the graph. How can we find the acceleration? It is the slope of the graph. Is it? Slope of graph. Slope of which graph? Slope of velocity time graph. It is equal to, here what is the slope of this graph? It is BD divided by AD. BD divided by AD. That is Y reading divided by X reading. BD divided by AD. Then what is AD here? AD is equal to OC തന്നെയാണ്. AD is equal to OC. Then here we can write what is the value of AD? AD is equal to OC is equal to, this time is T ആണ്. It is T. That is we can write, we know that acceleration is equal to change in velocity divided by time ആണ്. Change in velocity divided by time ആണ് acceleration. Then we can substitute the values. What is BD? BD is equal to V minus U. V minus U divided by, what is AD? AD is equal to T. Okay, so we can write that is this change in velocity divided by time. That is we can write A is equal to V minus U divided by T, or from this equation that is AT. AT is equal to V minus U, or we can write V is equal to U plus AT. U plus AT. നമുക്ക് U നെ ഇങ്ങോട്ട് കൊണ്ടുവന്ന അല്ലെങ്കിൽ this AT. V നെ ഇങ്ങോട്ട് കൊണ്ടുവന്ന plus I plus U plus AT. Okay, got it? Then V is equal to U plus AT. This is a first equation connecting velocity and time. This is the velocity time relation. V is equal to U plus AT. Okay. For velocity time relation, V is equal to U plus AT, where V is the final velocity of the object and U is initial velocity, A acceleration and T is the time taken to change the velocity from U to V. Okay. Now we are going to second equation. Second relation is the position time relation. Position time relation. To find the position time relation, we are going to find the area under velocity time graph. What is area under velocity time graph? Area under velocity time graph gives displacement or distance travel. From area under velocity time graph gives distance traveled by the object. Distance traveled by the object. But from the graph, we can write it's a distance traveled by the object. From the graph, the distance traveled by the object is equal to area under the graph. Our graph is, this is our graph from A to B ആണ് നമ്മുടെ graph. Is it? That is the area under this graph. This is the shaded portion is the area under the graph. Okay. This area under the graph, the area of, we can write this is the area of O, A, B, C. O, A, B, C. If this area, it is the, what's the shape of this shaded portion? It's a trapezium. Otherwise, we can consider it as a one triangle and one rectangle. Okay, so area of OABC is area of a trapezium, or which is equal to area of rectangle OADC. OADC plus area of triangle. It's a triangle ABD. Area of rectangle OABC plus area of triangle ABD. Okay. Then what is the area of, how can find the area of rectangle? Area of rectangle here, OA into OC. OA into OC plus, what is the area of, how can find the area of triangle? Half into AD into BD. AD into BD. We can substitute these values. What is OA? Here what is OA? OA is equal to U. OA is U. OA is equal to U into, what is OC? OC T. OC is equal to T plus half into, what is AD? AD is equal to OC that is T into, that is BD. BD is equal to V minus U. V minus U. Then from our first equation, what is our first position for first equation? Velocity time relation. What is velocity time relation? From velocity time relation, we know that V is equal to U plus AT. From here, what is V minus U? V minus U is equal to AT. This we can substitute. This നമുക്ക് equation 1 എന്ന് കൊടുത്താൽ this equation 2. Substitute 2 in 1. Equation 2 in 1. Then equation 1 become equation 1 become, it's a distance traveled by the object, so we can mark as S is equal to ut plus half into t into, instead of that v minus u, we can write at. That is S is equal to ut plus half a, but 2 t's are there, so t square, t into t is square. The second relation, the position time relation, S is equal to ut plus half at square. Okay, where S is the distance traveled by the object, u initial velocity, t time taken, a acceleration of the object. Got it? The second relation, the position time relation is S is equal to ut plus half at square. The next, we are going to find the position velocity relation. To find the position velocity relation, we know that from the VT graph, distance traveled by the object, it is equal to the area under the graph. Here in our graph, it is the shape of trapezium. So we can write the distance traveled by the object is equal to area of trapezium. Area of trapezium. Trapezium name what's the name of the trapezium? OABC. OABC. So we can write distance S is equal to, how can find the area of trapezium? Area of trapezium OA plus BC. OA plus BC divided by 2 into OC. OA plus BC divided by 2 into OC. OA plus BC divided by 2 into OC. Okay. Then we can substitute the values. What is OA? OA is U. OA U U plus what is BC? BC V V divided by 2 into OC OC, it's a time t. Okay. Here we are finding the relation between position and the velocity. So we want to remove the time t. So from the equation 1, that is first velocity time relation. What's velocity time relation? V is equal to u plus at. From here we know that v minus u is equal to at, or what is t? T is equal to v minus u divided by a. We can substitute the value of t from here to this equation. Then this equation become u plus v divided by 2 into, instead of the t, v minus u divided by a. Okay, that is this equal to v plus u into v minus u divided by 2a. V plus u into v minus u divided by 2a, which is equal to, we know that a plus b into a minus b is equal to a square minus b square. So v plus u into v minus u can be written as v square minus u square divided by 2a. Okay, so we can write this equation S is equal to B square minus U square divided by 2A, or first multiplying this, then we can write B square minus U square is equal to 2AS, or B square is equal to U square appare പോകുമ്പോൾ plus U square plus 2AS. But this is the third relation, position velocity relation. V square is equal to U square plus 2AS. Okay. Equations of motions are, first, velocity time relation V is equal to U plus AT. Let's relation connecting velocity and time. Second one is the position time relation. S is equal to UT plus half AT square. And third one is the position velocity relation, that is V square is equal to U square plus 2AS. Okay, thank you.